Hello guys, good evening. Welcome to our YouTube channel. In the last video, you understand what data science is, its basics, and how it impacts the regular and the organization life. In this video, what we'll try to understand? Statistic, and why statistic unlocks data's true power. Next 5 to 7 videos will be dedicated to stats only, because as you understand, stats lay down the basics of data science. Without statistic, the insight which gets generated from the data science model makes less sense. So if you understood statistic, you will be able to prepare the model in more meaningful ways, right? Now every single day, as we know, that quintillion bytes of data are generated. But here is the catch. Data itself has no value. Think of raw data like a crude oil. Unless the crude oil is refined, you cannot fuel your car or fly a plane or light up your house. So stat is nothing but that refinery which refine the raw data. It converts raw data into insight, decisions and predictions. In this series, we'll understand why stats is the backbone of data science and why without it, even the most advanced AI model will fail. Okay, so let's move to the next slide. Stats basically have two sections. One is descriptive statistics and one is inferential statistics. So when you see descriptive statistics, what you do? You summarize, visualize and understand what your data reveal with powerful insights, right? Just imagine this is the raw data, and this you create some kind of graph, some kind of chart or some kind of line graph to understand what data is saying with the help of descriptive statistic. If we go to definition, it summarizes data to answer the question what happened, means historically what have happened. The common tool which needs to understand is mean, median, mode to reveal the central tendency, supported by chart in tables to visualize pattern. Now let's take an example. Describing a company's average salary means what is the average salary of a company. We take one of the tool called mean, and when it comes to 8 lakh or 10 lakh per annum, we say that the company's average salary is 8 lakh or 10 lakh rupees per annum. In a basketball match, there are more than 10 players or 7 players. If you take height of everyone and take the mean, again one of the tool of statistic, it comes out maybe like 7 feet is the average height of all the players. Some players might be 7 feet 5 inch, some players might be 6 feet 10 inch, but the average height or the mean height comes to 7 feet. Now it also identifies the outlier. Just imagine if a player is 8 feet long, it will automatically pull out the average, right? So it identifies values significantly which is different from the rest and which are crucial for the accurate data analysis and decision making. Just imagine one of the guys is 8 feet 5 inch long and other guys are 6 feet 10 inch long. That does not mean that the average height is close to 7.5, because that one guy has pulled out the complete average. What we'll do, we'll remove that person from the data and take all those people in the calculation who follow the normal tendency, right? So what is the analogy over here? Think of descriptive statistic as a photo album capturing the past event, helping you understand what your data truly reveals. So it is what happened. Now the other one is, the next part is inferential statistic one. So what is the inferential statistic? Descriptive statistics tells you about the past, and the inferential statistics take the inference and predict and decide the confidentially using the data from sample to understand the bigger picture. Now what it does, it moves beyond the data or beyond the descriptive statistic to predict and generalize about a large population from a sample. Now what are the key tools over here? In descriptive statistic, key tools were mean, median or mode. What is the tool over here? The tool over here is probability, hypothesis testing and confidence interval that quantifies uncertainty and evaluates the prediction reliability. You might have seen a lot of time in the news about the exit polls, right? What happens over there? Did they check the entire population of a state or a district or a nation to actually tell what is the voters' mood? No, they survey the sample of people. They take the inference of the sample, so they ignore the entire population, but they take the sample of few people and then predict party X, means BJP or Congress or someone, winning by 52%, 55% of the votes. They don't have time to go and collect survey from each and every person, so that take representative sample of the population and take the inference out for the population. That is called inferential statistic. Again, descriptive is what happened in past, and inferential is to get the inference out of the population and predict the outcome. So it also helps us in forecasting analogy, like predicting the next photo in the album. If you see the album, what happened till now, and inferential statistic will help in predicting the next photo in the album. So what is the impact of it? It is essential for data scientists to make decision under uncertainty by turning data into actionable insight, right? So that is the main difference between descriptive and inferential statistics. Now the next slide, why data scientists must master statistics. Okay, now just imagine you are analyzing a loan application, okay, where the monthly income ranges from 20,000 to 80,000 for most of the applicants. But there is one application where the monthly income is 5 crore rupees. Okay, let's try to understand this. If the monthly income is 20k to 80k, right, and there is one person whose monthly income is 5 crore rupees, what will happen? Don't you think that the overall average will be pulled up? The overall average, if we include this 5 crore person, might goes to, if we have 100 to 500 people, might goes to 5 lakh or 10 lakh rupees per month. Don't you think it is wrong with these set of people, who are doing 20k, drawing 20k to 80k salary? So what stats does, it tries to understand the mean of the population and then try to understand if we have to remove any kind of outlier which is pulling out or pulling down my overall average. Just imagine if a person is earning 0 rupees per month and the person who's earning 80k. So if there are folks who are earning 0 rupees, or who are folks who are earning 10 or 5 crore rupees a month, don't you think they are outliers? If, because they might pull up or pull down or drag down the overall average, right? Using descriptive statistic like mean, median or box plot, detect these kind of anomaly, right? So when you do box plot, or when you, so how the box plot looks like, give me a second, I'll draw it for you. So a box plot looks like this, where your box plot entirely sits over here and all the outlier sits over here, like over here. So what it does, it makes you understand what is the overall distribution of data is and where the outlier lies, so that you can make a constant or cognitive decisions, right? Then once you understood the outlier, what you can do, you can ignore the outlier which can mislead the machine learning models, and then it will help in doing the accurate prediction, ignoring the inaccurate prediction using the unreliable data or unreliable result. Okay, so it helps you make the accurate prediction by using the accurate data. When effective data cleaning happens with statistical method, it becomes essential to maintain model accuracy and trustworthiness. Okay, so that's what I'm saying. Before moving to any kind of model, if you are able to understand the data distribution, if your data is distributed like this or not, so most of your population lies here. We'll understand this in more for detail section, but most of your data lies here. This is called normal probability curve. Most of data lies here only. So understanding data distribution, if the distribution is normal, it is basically ready for the modeling. If the distribution is skewed like this, or if the distribution is skewed like this, you need to understand what I have to improve or what I have to remove and fix before going into modeling, right? So every data scientist must have the knowledge or understanding of the statistics to make sure that the data which you are using is sane, so that the model which is coming as an output of this exercise gives you the accurate results, right? Now let's move to the next slide. Why data scientists must master statistics to decide with confidence? Just imagine Flipkart or Amazon, who is the e-commerce giant. They want to test one of the design which they have of their app. So what they do, they run some kind of A/B test. A/B means one set of population called A, one set of population called B. A/B test means they show one group a similar different screen, another group a different screen. The result were group A or group B had 3% more purchase than the group A or B itself, right? But statistic reveals that this gain is real or just by chance. It means it will happen every time or it happens just one time with the chance, right? Hypothesis testing also evaluate if observed difference are statistically significant or not, right? Without statistical help, business, just imagine if they see that okay, group A has shown 3% more purchase, and without using statistic, they invest millions of dollars in revamping the app, and at the end they got to know that this was not statistically significant but happened by chance. So when they made it live, the CTR or the revenue increase was not there because this 3% or 4% more purchase was happened by chance. That is why before taking any kind of decision, it should make statistically significant so that when a business is making a decision, it is data backed. So applying scientific method ensure data driven decision that fuel competitive advantage and sustainable growth as well. Okay. Now, why data scientists, again I'm saying why data scientists must master the statistic thing is because just think about few of the algorithms. If you already know linear regression, okay, so what linear regression is? Linear regression, basically what it does, it fits a line of fit. Sorry, it is not the line is not straight, but it is the data point and it tries to fit a line, minimizing the error with least square method. So in linear regression, it happens that if just imagine if your data, if there are few data points who are residing here or who are residing here or who are residing here, here, if you don't treat this data, what happens, your line might go this way and it will leave a lot of normally distributed data points. So statistic helps you understand what you can achieve with the same data. Now in logistic regression, what is the outcome? In logistic regression, basically it's a classification model. The outcome generally goes to into a categorical variable which is 1 or 0, means success or failure. So if you don't read the data before running your model with statistically significant approach, what will happen? The output of logistic regression will be biased. Same happens with decision tree, where you choose split using static metric like Gini index. So all these algorithms, they take help of data, and that data should be seen with the help of statistically significant matter, right? Now, why statistic unlocks truth beyond correlation? Just see this image of iceberg. So what is iceberg? The iceberg looks small on top of the water and huge in bottom of the water. Means just an iceberg hides most of its mass underwater. Static also reveals the unseen factor, like what is influencing the data. Like just imagine in summer, sales of ice cream increases, at the same time drowning into sea or river deaths also increase. So does it have any kind of correlation? Like ice cream sales and drowning death have any kind of correlation? You might say no, but there is a summer can cause sales in ice cream and people going to sea or going to river to take a bath and getting drowned over there, right? So fitting pieces to reveal true cause. Distinguishing correlation from causation is like solving a puzzle. Means ice cream sale and drowning death cannot be correlated, but they both can be caused by summer, right? Distinguishing correlation from causation is like solving a puzzle where you identify and confound and apply all type of control to help complete the picture and prevent false kind of conclusion, right? Now moving to the last section, the transformative power of statistic across industry. In healthcare, all the clinical trial use statistic method to compare treatment and placebo groups. They assess drug efficacy, and ensure real therapeutic effect. So they also say that they are 99.9% confident that this drug will cure this particular type of disease. If they say we are 94 or 95% confident, this drug might not pass, right? So in healthcare, all the statistical significance of a drug efficacy is very important to make sure that the drug is efficient. Same while building the risk model with regression and probability, you need to say I'm 97% confident that the person is not risky for giving the loan. So what happens over here? If you say that I'm only 70 or 80% confident, the finance company might not pass the loan for a customer, right? In sport analytics, you analyze the person's metric, like what is his strike rate is 50, or his average is 50 and his strike rate is 140 per match, and in a pressure situation, out of 10 times he plays match winning inning for 7 times, right? So all these things help cricket experts or coaches take the right decision. When a team is in pressure, they will send the batsman who is able to handle the pressure 7 out of 10 times to chase the run or to chase the score. Okay, so this is where the statistic help in different industry, be it sport, or be it healthcare, be it finance, right? Let's move to the next slide. Now, before ending this, let me give you a very simple, I would say, very simple analogy. Imagine we all love food. So imagine walking into a buffet with 100 dishes, right? You can't taste everything. So what you do, you take a sample of plate for 5 to 6 items. If they are too spicy or too sweet, you can guess that the overall buffet is might be spicy or might be sweet. You can't taste all the 100 dishes, right? So you take only 4 5 different samples, not only the vegetables or the chapatis or rice or gravy. You take everything in small amount for like 4 5 items and then say, okay, the overall food might look like sweet or spicy. That is statistic, using a very small sample to make sense of the bigger picture. Now data scientists don't have time to look at every customer, every click, and every event. So what they do, they rely on sampling, probability, and inference. Okay, so to end this session, statistic goes beyond complex math. It is about making very quick, smart decision with less data, even if you don't have the entire data. So from predicting election to testing vaccine or even recommending your next Netflix movie or series, stats shape our world. In the next classes, we'll explore essential data type, categorical, numerical, or ordinal, and we'll understand statistic in more depth. So if you have liked the video, please like and subscribe our channel. This series will be huge. We are going to add more than 100 videos to complete the data science journey. If you follow this, I can guarantee you that you will be job ready and industry ready. It is a very quick start for us right now. In coming weeks, you will see we are diving deep into the more complex portion of data science stats and all those things which help a person help the business in revenue making. Thank you guys and have a good day.